All right, so we're still in example 2 of the 7C notes, and we are to simplify each complex fraction completely using method 2. So example C here, you can see that we've got the complex of a fraction in the numerator and a fraction in the denominator. So when we compare the denominators, they're the same, so that's the LCD. So we want to multiply the numerator by that LCD, which is x plus 1, and we also want to multiply the denominator by x plus 1. And when we distribute it, we'll want to also multiply the second side by the x plus 1. All right, so when we do this, I get x plus 1 times 2, so I'm going to distribute that through and get 2x plus 2. And then when we multiply it times the second one, the x plus 1s are going to cancel, and then that's just going to leave me with a plus 3. Divided by, then distribute it through the denominator, so here my x plus 1s cancel, and I get 1. And then when I multiply it times the right side, I'm going to get, distributing it through, I get x squared plus x. All right, so now I want to simplify it and make it look a little bit better, so I can add my 2 and 3 here. So this is going to be 2x plus 5, and I'm going to rearrange this so it's in descending order. X squared plus x plus 1. This will not factor, and it will not reduce. Now, example D, starting here, we're going to be using some of our exponent properties that we know about negative exponents. Recall that x to the negative 1 is actually 1 over x. And recall that an exponent only applies to the one thing it's next to, not both of them, unless there's a parentheses. So this is going to be 3 times 1 over x, which is going to actually be 3 over x. Then plus, then here I have x to the negative 2 and y to the negative 1. So I'm going to have a fraction, and the x to the negative 2 is going to drop to the denominator, and the y to the negative 1 will drop to the denominator, and we get a positive exponent with a 1 on top. The denominator, y to the negative 2, is going to become 1 over y to the positive 2, plus, and then again, the x doesn't have an exponent, so it's going to stay on top. And then y to the negative 1, that y to the negative 1 is going to drop and become y to the positive 1 right there. All right, so now we have it written, and you can see that this is actually a complex fraction because we have fractions inside of our fractions. So we want to multiply through by our LCD, and the LCD, looking at all of the different denominators, looks like with x's, I have an x to the second is the largest exponent, and with my y's, I have a y to the second. So that clever one then is going to be x squared, y squared. And I distribute it through, so I'm going to put it on the other side as well. And then I'm going to multiply. So here my x's are going to cancel, and I'm going to be left with 1x. So that's an x, y squared, and a 3. So that's going to be a 3x, y squared, plus, on the second fraction, the x squareds cancel, and one of the y's cancel. It leaves us with 1y times 1, which is just y. Then in my denominator, the y squareds cancel, and that leaves me with x squared times 1, so x squared, plus here, one of my y's cancel, and so now what I have left here is an x times x squared, so that's x cubed, and then 1y. You can tell, you can go ahead and try factoring. This actually factors a little bit, but you can see if we take the x squared out, we're not going to have a 3. So, and if we take the y out, again, we're going to have a 3. This will not factor and reduce. You should think about it always, though. All right, one more example. E, I have, this time I have a parentheses, 3x to the negative 1. So that whole parentheses then is going to go into the denominator to a positive 1. Then minus 2 over, and then 5x to the negative 1. The 5 stays on top, no exponent, and x to the negative 1 drops and becomes over x. And then plus 2. Now I need to think about what my LCD is going to be. I have a 3x and an x. It's just so blurry. Hang on. Better? Okay, so I have a 3x and an x. So my common denominator's got to have a 3 and it's got to have an x. So 3x over 3x. And then I'll put it on the other side as well. So when I multiply that, my 3x is canceled there and leaves me with 1 minus, and then 2 times 3x is 6x. My x is canceled here, and that leaves me with a 3. And 3 times 5 is 15. And then 2 times 3x is a plus 6x. And again, that won't reduce, and so that's my answer. So now what I'd like for you to do is try problems F and G. So F is more like some of our earlier ones, and G is like those at the top of the page. All right, we'll check you next class.